Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and today we are going to talk about composite functions. We're going to break down what composite functions are, how to evaluate them, and how to write one function inside another. So to start, let's start with the recap of function notation. So in previous math courses, you might have seen notations like this, f of 3. What that means is we have our function f, and the 3 is the input. So in this example, we have f of x is equal to 3x squared plus 2x. And what we want to do is we want to evaluate what f of 3 is. So meaning if we have 3 as the input, what is going to be our output? And you might remember that all you need to do was substitute this input value in place of the variable in the question. So for example, f of 3 is going to be 3 times 3 squared plus 2 times 3. So all you've done is put this 3 in place of x. Next, all you need to do is evaluate this, and you're going to end up with 33. So now similarly, if we have f of negative 1, your new input value is negative 1. So everywhere that you see x, you're now going to put in negative 1. So this means this is going to be 3 times negative 1 squared plus 2 times negative 1. And this is going to end up equaling 1. So what we aim to do with this function notation is to extend it to substitution of other functions, not just numbers. And this is what is known as composition of functions or composite functions. Okay, so let's scroll down. So here we have our composite function. And these three expressions are equivalent. So here this is f of g of x, and then this little circle that you see here, that is also of. So we would read this as f of g of x. And then finally, you can also write this as f of g of x. All these mean the exact same thing. So when substituting one function inside another, it is important that we have the correct notation. So in all three of these, g of x is going into f of x. Okay, so let's start with an example here. If we have f of x is 2x plus 1, and then we have g of x is x squared minus 3. We wish to find f of g of x and g of f of x. So let's start with f of g of x. So notice our input is now g of x. Okay, so we're going to start with our function f, which is 2x plus 1. But instead of our input being x, our input is now g of x. So this is going to be written as 2 times g of x plus 1. But since we know what our g of x is, we can go ahead and substitute it in. So g of x is x squared minus 3, which means this is now 2 times x squared minus 3 plus 1. And now all you have to do is expand this and simplify it, and you should end up with 2x squared minus 5. Okay, next, let's go ahead and evaluate what g of f of x is. Okay, so this is going to be different because f is now our inside function. So we start with our g of x, which is x squared minus 3. But instead of our input being x, our input is now f of x. So this is going to be equal to f of x squared minus 3. And again, because we know what f of x is, we can go ahead and substitute it in. So that becomes 2x plus 1 all squared minus 3. And then we're going to expand that and simplify it, and this ends up being 4x squared plus 4x minus 2. So again, note that the order of the substitution here does matter because we created two completely different results. Now, suppose we want to find f of g of 3. Okay, so we want f of g of 3. What this means is we're putting 3 into our function g, figure out what that is, and then take that value and put it into f. Okay, but because we already know what f of g of x is, we can actually just input 3 into the x. So this means since f of g of x is 2 times x squared minus 5, f of g of 3 is going to be 2 times 3 squared minus 5. And this is going to give us 13. So, to recap, the notation f of g of x is different from g of f of x. So composite functions are created when one function is inputted into another. So when we have f of g of x is the inside function, and it goes inside f of x. But if we have g of f of x, then that means f is the inside function, and that is going into the function g of x. So now, using this knowledge, can you determine the equation for f of g of x if f of x is x squared plus 2x and g of x is x plus 1? Leave your answer in the comments below and let us know if you'd like to see more content on composite functions in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.